background of what are the things that we discussed. Reminder based problems will be of the form numerator by denominator. What will be the remainder? All the questions will be of the form numerator by denominator. What is the remainder? So there are two cases possible. There are two cases possible. Numerator and denominator are co-prime to each other. Numerator and denominator are co-prime to each other. Are co-prime to each other. Are co-prime to each other. Numerator and denominator. That means HCF of base in numerator, HCF of base in numerator, comma denominator. It is nothing but 1. Two numbers are said to be co-prime to each other if their HCF is 1. Two numbers are said to be co-prime to each other if their HCF is 1. If numerator and denominator are co-prime to each other, there are multiple ways. One is a negative remainder concept. One is a negative remainder concept. And another is an Euler's theorem concept. Euler's theorem. Yesterday we discussed all this. Next one will be Chinese remainder theorem concept. Chinese remainder theorem concept. Next one will be Fermat's theorem concept. Write down in the same way. Write down in the same way. One is a negative remainder concept. Another is an Euler's theorem concept. Chinese remainder theorem concept. And the last one, it is a Fermat's theorem. Last one, it will be Fermat's theorem. When the Fermat's theorem is used, when the denominator, it is a prime number. When the Fermat's theorem will be used, when the denominator, it is a prime number. When the denominator, it is a prime number, Fermat's theorem is used. When the Chinese remainder theorem is used, when the denominator, it is a composite number. When the denominator, it is a composite number. If the denominator, it is a composite number, then the Chinese remainder theorem is used. A prime number is a number which is only divisible by 1 and itself. Which is only divisible by 1 and itself. Chinese remainder theorem is used when the denominator, it is a composite number. A composite number is a number which has got more than two factors. More than two factors. There are three kinds of numbers based on factors. There are three kinds of numbers based on factors. Based on factors, there are three kinds of numbers. Only one factor. Only one factor. If there is only one factor, then the number is called 1. If there are only two factors, if there are only two factors, if there are only two factors, then the number is called a prime number. Then the number is called a prime number. If there are greater than two factors, if there are greater than two factors, then the number is called a composite number. Then the number is called a composite number. Depending upon the number of factors, depending upon the number of factors, there are three kinds of numbers. A number which has got exactly one factor. A number which has got exactly one factor. That number is called 1. 1 is a factor for every number. 1 is a factor for every number. Number which has got exactly two factors. The numbers which has got exactly two factors, that is 1 and itself. 1 and itself. Numbers which has got exactly two factors are called prime numbers. A composite number is a number which has got greater than two factors. Numbers which have got greater than two factors are called composite numbers. Numbers which has got exactly two factors are called prime numbers. Only on prime numbers in my paid batch I will discuss 6 to 8 hours class so that a student will understand all the 15 to 18 models of questions that can come in prime numbers. Numbers, the classification of numbers based upon factors. Only one factor, only two factors and greater than two factors. So, negative remainder is used when the denominator can be either a prime number or the denominator, it is a composite number. Negative remainder can be used when the denominator it is a prime number or the denominator it is a composite number. Denominator, if it is a composite number, I will use Euler's theorem also. I will use Euler theorem also. Listen carefully to the next few lines, whatever I am saying. If you are unable to solve the problems in less time by using negative remainder concept, if the denominator it is a prime number, then make use of Fermat's theorem. If you are unable to get the answer by using negative remainder concept, when the denominator it is a prime number, use this concept of Fermat's theorem. Step number 2. If you are unable to find the negative remainder concept, when the denominator is composite, go to Euler's theorem. If that is also not giving you the answer, then go to Chinese remainder theorem. Then go to Chinese remainder theorem. This table is of extreme importance to me. If you understand this table, entire reminders chapter will be extremely clear to you. Again, I am repeating this point. If the negative, I will put it in a next slide. All the remainder based problems will be of this type. Either the denominator can be, there are only 3 cases possible. If the denominator it is 1, then it is called a natural number. 4 by 2. 4 by 2 can be optimized as 2 by 1. 6 by 2 can be optimized as 3. 8 by 4 can be optimized as 2. If numerator and denominator are co-prime to each other, if the denominator it is 1, then it is called a natural number. If the denominator it is a prime number. So we are first understanding what are all the cases that can be possible for a denominator. Denominator can be 1. If the denominator is 1, then it is called a natural number. If the denominator can be a prime number, denominator can be a composite number. So 2 cases will arise. What will happen if the denominator is a prime number? What will happen if the denominator it is a composite number? Denominator it is a composite number. See here, sir. Reminder. Slowly, concept by concept, not a single doubt, you will get it in the class. Numerator by denominator. If the denominator, it is a prime number. If the denominator, if it is a prime number, first use negative reminders. If you are able to solve it very quickly, by using negative reminder, stop it. If it is taking more time, then go to Fermat's theorem. This is an extremely important slide, sir. If the denominator, if it is a composite number, first try to solve using negative reminder. If it is not giving you answers in shorter time, use Euler's theorem. If it is also failing, then use Chinese remainder theorem. Please put it as very, very important slide, sir. Very, very important slide. This slide will tell you when to use which concept. Very, very important slide. If the denominator it is a prime number, first I will check with the negative remainder. If it is taking more time to solve a question, then we will get into Fermat's theorem. We will solve first by using negative remainder. If it is taking more time, then I will get into Euler's theorem. If it is also taking more time, then I will get into Chinese remainder theorem. Now, yesterday's class, we did this and we also did this. Now we will continue with The next pending topics. First problem I did, second I did, fourth, fifth, sixth, seventh, eighth. Power to power, these also we did it, 11th, 12th, 13th, 14th, 15th, 16th. Euler theorem also we have discussed yesterday. All these problems we discussed. In one of the comment, a student asked me to solve this question again. I will take up this question after I complete the today's topic. Now please write down. The extension of Fermat's theorem. Almost close to 40 to 50 problems. I'll solve it in today's class. Euler's theorem. What is Euler's theorem? Euler's theorem states, Euler theorem is used to find out the remainder when you divide a number by composite number. A power phi of n by n, it is 1. Where a and n are co-prime to each other, and the denominator, it is a composite number. Any composite number can be written as power of prime numbers. P1 power x, P2 power y, P3 power z. So what do you mean by quotient of n? Quotient of n is nothing but n into 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3. 1 by P3. We have seen yesterday this case, and we have done a lot of problems where the denominator it is a composite number. Now see here, we will take up Fermat's theorem. The difference between Fermat's theorem and Euler's theorem is, Fermat's theorem is used when the denominator it is a prime number. Euler theorem is used when the denominator it is a composite number. N is a prime number. If n is a prime number, if n is 11, this can be written as only 11 power 1. If n is 29, this can be written as 29 power n. So the quotient of a n, which is a prime number, it is nothing but, n is nothing but P1 into 1 minus 1 by P1. So any prime number can be written as a singular power of a prime number. 23 can be written as 23 power 1. 31 can be written as 31 power 1. So P1 into 1 minus 1 by P1. These are nothing but P1 minus n. Very, very important point. Please write down. Quotient of a prime number. It is nothing but prime number minus 1. Take the quotient function of a prime number. Quotient function of a prime number is always given by prime number minus 1. How you got prime number minus 1? Here the n is a composite number. Here the n is a prime number. Any prime number can be written as a singular power. 11 can be written as 11 power 1. 29 can be written as 29 power 1. So P1 can be written as P1 power 1. So it is nothing but P1 into 1 minus 1 by P1. P1 cancel. Answer is nothing but P1 minus 1. P1 it is a prime number. Very, very important key point. So in Fermat's theorem, if n is a prime number, it will become a power p minus 1 divided by p, it is nothing but 1. A power p minus 1 when divided by p, it is nothing but 1, where p is a prime number. Very, very important concept. The difference between Euler theorem and Fermat's theorem is, Euler theorem is used when the denominator it is a composite number. If the denominator it is a composite number, Euler theorem is used. Fermat's theorem is used when the denominator it is a prime number. If the denominator it is a prime number, then format, this will become remainder of quotient function of a prime number will become a power p minus 1 divided by p equivalent to 1. A and p are co-prime to each other. A and p are co-prime to each other. P is nothing but a prime number. 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 These very, very useful wherever the negative remainder is failing. Examples. Examples. First question. Remainder 1. 3 power 6 by 7. 3 power 6 by 7. First check whether the denominator it is a prime number. 7 is a prime number. 7 minus 1 is 6. So answer for this question is nothing but 1. Answer for this question is nothing but 1. 23 power 12 divided by 13. 23 power 12 divided by 13. A power p minus 1 divided by p. It is 1. If it is 13, 13 minus 1, it will be 12. It will be 12. I hope the idea it is clear. 9 power 37. 9 power 37 divided by 19. 9 power 37 divided by 19. If you use a negative remainder, 9 square, 9 cube, we have to find out which power of 9 when divided by 19. I will get plus 1 or minus 1. But by using Fermat's theorem, directly you will get the answer. If the denominator it is 19, 19 minus 1, 18. 18 multiple till 37. 18 twos are 36. Remaining 9 power 1 divided by 19. These are nothing but 1. 1 into 9 is nothing but 9. 1 into 9 it is nothing but 9. If the denominator it is p, power of a numerator base, it will be p minus 1. It will be p minus 1. Two more problems. Fourth question. 5 power 57. 5 power 57 divided by 29. 5 power 57 divided by 29. If the denominator it is a prime number, then it will become 2 power 28. 28 twos are 56. Another 1 power of 2 is remaining into 29. So these are nothing but 1. 1 into 2, it is nothing but 2. 1 into 2, it is nothing but 2. 1 into 2, it is 2. One more question. One more question. 7 power 49 divided by 17. 7 power 49 divided by 17. If the denominator it is 17, power should be moving in the cyclicity of 16. 7 power 16 by 17 it is 1. So 7 power 16 power 3 into 7 power 1 divided by 17. Divided by 17. These are nothing but 1. 1 into 7, answer is nothing but 7. 1 into 7, answer is nothing but 7. Very, very important problems. This is popularly called as Fermat's theorem. These popularly called as Fermat's theorem. Reminder 1. A power p minus 1 divided by p, it is 1. Please make a note. Numerator base value and the denominator both should be co-prime to each other. A and p are co-prime to each other. Denominator p, it is a prime number. Fermat's theorem is used when the denominator it is a prime number. I hope the introductory problems on Fermat's theorem, it is clear to you. Next slide, very, very important derivative of Fermat's theorem. We are going to solve it. Pay utmost attention to it. Pay utmost attention. I hope the idea it is clear. Now before that, any introductory problems are there? Fermat's theorem introduction which we have done. This one. Reminder 1. 52 power 30 So a power p minus 1 divided by p, it is nothing but 1. So 31, it is a prime number. So answer is 52 power 30 divided by 31. Answer is nothing but 1 based on the Fermat's theorem application. Already we did the basic introductory problems. 29, it is a prime number. So 28. 28 twos are 56. Another 17, it is remaining. 17 divided by 29, which is nothing but 17. Second question also, it is clear. Right. Third question. Before we solve the third question, let me see if I can create some very, very good questions on spot. Questions. 5 power, for example, 5 power 23 divided by 13. 5 power 23 divided by 13. Now, one is, in this problem, negative remainder seems to be the best method. Negative remainder directly you can use. 13 means power can be 12. 12 twos are 24. Coming back, doing backtracking, it will be cumbersome. Which power of 5? When divided by 13, I will get plus or minus 1. 12, 11s are 22 into 5 power 1 divided by 13. 25 divided by 13. 13 twos are 26 minus 1. Minus 1 power odd minus 5. Positive remainder, it is nothing but 8. Positive remainder, it is nothing but 8. Very, very easy question. In fact, Fermat's theorem will take little more time. 13 means power is 12. 5 power 24 by 13, it is 1. Question is 5 power 23. So coming back, it will be little cumbersome. So for certain problems where the denominator, it is a prime number, negative remainder seems to be a very, very interesting logic. Very, very interesting logic. Now, for example, if it is 4 power 31 by 17, 4 power 31 by 17, 4 power 31 by 17. Use the same concept as third problem. Which power of 4 when divided by 17? I will get plus 1 or minus 1. 4 square, it is 16. Here directly you are getting it. So these is nothing but 4 square power 15 into 4 power 1 divided by 17. 16 by 17 minus 1. Minus 1 into 4 minus 4. Positive remainder, it is 13. Positive remainder, it is nothing but 13. Positive remainder, it is nothing but 13. Now let us see. Suppose if it is 5 power 31 by 17. 5 power 31 by 17. 4 power 31 divided by 17 can be solved by using negative remainder. 4 square, it is 16. 16 by 17, it is minus 1. Directly you got. 5 square is 25. Remainder is 8. 5 cube, 125. 17 8s are 136. No, it is not giving you. So that is the reason here Fermat's theorem will be helpful. Here Fermat's theorem will be helpful. How the theorem will be helpful? Let us see. We will use, yesterday in Euler's theorem, we have seen the backward approach, or most popularly called as backtracking method. Backtracking means you have to determine the known, from that known you have to determine the unknown. 5 power 31 by 17. Because denominator it is 17. Denominator it is 17. Numerator can be 16. So 5 power 16 divided by 17, it is 1. These according to Fermat's theorem. According to Fermat's theorem. But according to the question, we require 31. According to the question, we require 31. We got 16. What is the multiple of 16 till 31? 16 twos are 32. So it is 5 power 32 divided by 17, which is nothing but 1. 5 power 32 divided by 17, it is nothing but 1. 5 power 32 can be written as 5 into 5 power 31 divided by 17 equivalent to 1. Listen carefully here, sir. From here, very good problem it is there. 5 power 32 we got. But according to the question, we need 5 power 31. So 5 power 32 can be written as 5 into 5 power 31. 5 divided by 17, 5. 5 power 31 divided by 17. I don't know x. When I further divide, answer does not change. Yesterday, the same kind of problem where the power of numerator is less than the quotient function. We used backtracking method. 5 by 17. 17 zeros are 0. Remainder 5. 5 power 31 by 17. We do not know the remainder, that is what we want. If I further divide, remainder does not change. If I further divide, remainder does not change. 5x, when you divide by 17, quotient is nothing but k, remainder it is 1. Dividend equivalent to divisor into quotient plus remainder. 5x equivalent to 17k plus 1. So 5x is nothing but 15k plus 2k plus 1. 15k plus 2k plus 1. 15k plus 2k plus 1. These are divisible by 5. These also divisible by 5. 2k plus 1. It is divisible by 5. So k minimum has to be 2. K minimum has to be 2. Why? Because 2k plus 1 equivalent to 5. 2k equivalent to 4. K is 2. K minimum 2. 5x is 35. X value is nothing but 7. X value is nothing but 7. Very, very good question. First we discussed the definition of a Fermat's theorem. Then we discussed how the negative remainder can also be used to get the answer very, very fast. Then we have seen the backtracking method. The notes will be very crystal clear. Each and every models that will come under a Fermat's theorem, everything will be discussed in detail. 5 power 16 divided by 17, it is 1. Multiple of 16 is 32. I want 5 power 31. 5 into 5 power 31 by 17, it is 1. 5 power 31 by 17, it is x. 5x divided by 17, it is 1. 5x is the dividend. 17 is the divisor. Quotient is k. Remainder, it is 1. Dividend equivalent to divisor into quotient plus remainder. 5x equivalent to 17k plus 1. 5x equivalent to 15k plus 2k plus 1. Divisible by 5, divisible by 5. 2k plus 1 should be divisible by 5. K minimum, it is 2. 5x is 35. X is nothing but 7. X is nothing but 7. X is nothing but 7. I hope this fifth problem, it is clear to you. Fifth problem, I hope it is clear to you. Next one. Let us do one more question so that this concept will be extremely clear to you. 11 power, for example, 23. 11 power 23 divided by 13. 11 power 23 divided by 13. Sir, I want to use a backtracking method. You can also use a negative remainder. In case if you are getting answer fast by using negative remainder, please use that logic. 1 minute, sir. Right. Backtracking, let us use. 13 it is there. 13 means power will be 12. So 11 power 12. 11 power 12 divided by 13. it is nothing but 1. A power p minus 1 when divided by p, it is 1. 12 2s are 24. So 11 power 24 divided by 13, it is nothing but 1. I want 23. So these are nothing but 11 into 11 power 23 divided by 13, it is nothing but 1. 11 into 11 power 23 divided by 13. 11 by 13, 13 zeros are 0, 11. 11 power 23 by 13, I want the value. When I further divide, remainder does not change. Remainder does not change. 11x when you divide by 13, quotient is k, remainder 1. So 11x is nothing but 11k plus 2k plus 1. 11k plus 2k plus 1. 11k, just 1 minute, sir. 11k plus 2k plus 1. 11k plus 2k plus 1. This is divisible by 11. This is divisible by 11. 2k plus 1 should be divisible by 11. If 2k plus 1, if it is divisible by 11, 2k plus 1, it is divisible by 11. K value, minimum value. You can also take higher values. Further divide, I will get the same answer. K minimum, it is 5. 11x equivalent to 13 5s are 65 plus 1, 66. 66 by 11. Answer for this question is 6. Answer for this question is 6. I hope the idea, it is clear. I hope the idea, it is clear. I am seeing the comments. If any valid doubts are there, then I'll discuss. I don't see any doubts in the comments, so we can move forward. We can move forward. I hope it is clear. Right? So this question, I hope it is clear. Next one, 6th question also we discussed. 7th one. These also we discussed sample problems. Now see here. Remainder 1. Remainder 1. 50 power 51 power 52 divided by 11. Based on this one. Based on this one. Let me do one more example. Very, very good question, sir. If the denominator, it is 11. If the denominator, it is 11. Remainder 1. A power p minus 1 divided by p, it is 1. When p is a prime number, when p is a prime number, and a comma p are co-prime, and a comma p are co-prime. So this will give you remainder 1, 50 power 10 divided by 11, it is nothing but 1. 50 power 10 divided by 11, it is nothing but 1. Yesterday we discussed power to power problems. Divide this power by this power. If I divide this power by this power, these are nothing but 51 power 52 divided by 10. I am checking what is the form of the number for 51 power 52. 10 5s are 50. Remainder, it is nothing but 1. So 51 power 52. When you divide by 10, quotient we don't know. It is 10k plus 1. So it is nothing but remainder of 50 power 10k plus 1 divided by 11. 50 by 11. 11 4s are 44. What is the remainder? 6. Very, very good question. If you understand Fermat's theorem, you can solve this question very, very easily. First step. The denominator, it is a prime number. 11, it is a prime number. So power has to be 10. Power has to be 10. 50 power 10 divided by 11. 50 power 10 divided by 11, it is 1. Second step. If the power is 51 power 52, 51 power 52 divided by 10, 10 5s are 50, remainder, it is nothing but 1. Dividend equivalent to divisor into quotient plus remainder. 51 power 52 is 10k plus 1. So 50 by 11, 11 4s are 44, answer is nothing but 6. Please put a star mark on this question. Another question. 9 power 25 power 37 divided by 7. 9 power 25 power 37 divided by 7. Same method we will try to solve. Same method we will try to solve. Fermat's theorem, first we did it for a single power, then I am raising power to the power. So these are nothing but, if it is 7, according to Fermat's theorem, 9 power 6 divided by 7 is 1. 9 power 6 divided by 7 is 1. Divide this power with the power for which you got 1. Divide the power by the power for which you got 1. 25 power 37 divided by 6. These are nothing but 6 fours are 24. Remainder it is nothing but 1. So 25 power 37. When you divide by 6, quotient is k, remainder is 1. Dividend equivalent to divisor into quotient plus remainder. 25 power 37, when divided by 6, quotient is k, remainder is 1. So substitute this in this equation. If I substitute this, these are nothing but 9 power 6k plus 1 divided by 7. So 9 by 7, 7 ones are 7, remainder it is nothing but 2. 7 ones are 7, remainder it is nothing but 2. I hope the idea it is clear. The more and more mathematical problems you will solve from a particular type, variety of questions, multiple models from a single question, the more and more you solve, the more and more confident you will be in clearing this examination in the first attempt. Otherwise, some basic questions, if I solve it in the live class, if you look at a mock question, you will fear thinking that this question is of a high level. High level or a difficulty is based upon your non-exposure on a particular concept. I hope third problem is clear and example related to third problem. Fourth is also clear. We will do one more example so that my students will be extremely comfortable with this topic. Another question. 7 power 13 power 29. 7 power 13 power 29 divided by 5. 7 power 13 power 29 divided by 5. Now let us solve. Third question based on this model. If the denominator it is 5, if it is 5, then 7 power 4 divided by 5 will be 1. 7 power 4 divided by 5, it will be 1. I hope this is based on a Chinese remainder theorem. Divide this power with this power so that you will come to know what is the form of 13 power 29 when you divide by 4. 4 3s are 12, remainder it is nothing but 1. So dividend is 13 power 29. Dividend equivalent to divisor into quotient plus remainder. Dividend equivalent to divisor into quotient plus remainder. Then convert that 13 power 29 of this form. So these 7 power 4k plus 1 divided by 5. 7 power 4k plus 1 divided by 5. 7 by 5. 7 by 5. 5 ones are 5. Positive remainder it is nothing but 2. Positive remainder it is nothing but 2. This model, 2 more questions I created on spot so that you will be extremely comfortable with this given topic. I hope the idea it is clear. Let me get into the fourth problem. Right after the class is over, you should not get a single doubt related to Fermat's theorem. Now, next one. Another question. Remainder 1, 2 power 2005. Remainder 1, 2 power 2005 is divided by 13. According to Fermat's theorem, denominator it is 13. It is a prime number. So 2 power 12 divided by 13, it is nothing but 1. First step. It is nothing but 1. Then divide these power with the power for which you got 1. 2005. If I divide by 12, If I divide by 12, 12 ones are 12. Next is 80. 12 six are 72. 85. 12 sevens are 84. Remainder 1. 2005. 2005. When you divide by 12, we do not know the quotient, but the remainder it is 1. We do not know the quotient, but the remainder it is 1. I hope the idea it is clear. Denominator 13. 13 is a prime number. So 2 power 12 divided by 13 it is 1. Divide this power by this power to check the form of 2005. 2005 when you divide by 12, remainder will be 1. Dividend equivalent to divisor into quotient plus remainder. So 2005 is nothing but of the form 12 into something plus 1. 12 into something plus 1 divided by 13. 2 divided by 13. 2 divided by 13. Answer for this question is nothing but 2. Answer for this question is nothing but 2. By using negative remainder, you will also get the same answer. Use the negative remainder concept. That also will give you the answer. Find out which power of 2. When divided by 13, I will get plus 1 or minus 1. 2 square divided by 13, 4. 2 cube divided by 13, 8. 2 power 4, 16 by 13, 3. 2 power 5, 32. 2 power 6, 64. 6. 633s are 198, 25. 4 into 2 power 1 divided by 13. Divided by 13. 65 by 13 minus 1. Minus 1 power even. It is 1. 1 into 2, 2. Both of them has given you the same answer. Both of them has given the same answer. I hope the idea it is clear. Fermat's theorem is used when the denominator it is a prime number. First single power we did it, then we did the highest power. Next one. Beautiful question, sir, it is. Fifth question is a very, very good question. Okay, the question I will write it again. 10 power 1, 10 power 10. 10 power 100, 10 power 1000, and so on up to 10 power 1 followed by 10 zeros. 1 followed by 10 zeros. 3 0 6 9, 10 zeros. This entire number, it is divided by 7. It is divided by 7. 10 power 10, 10 power 100, 10 power 1000, 10 power 10 power 4, 10 power 10 power 5, and so on up to 10 power 1 followed by 10 zeros divided by 7. Let us see if there is any pattern that will come. Is there any pattern that will come? Let us see it. First one, 10 power 10, 10 power 10. Divided by 7, because it is 7. Power is nothing but 6 into 10 power 4 divided by 7. Divided by 7. These nothing but 1 based on a Fermat's theorem. 10 by 7. 7 ones are 7. 3 power 4. 3 power 4 is 81. 81 divided by 7. 7 11s are 77. Remainder is nothing but 4. Remainder, it is nothing but 4. Similarly, if I take the second term is nothing but 10 power 100. 10 power 100 divided by 7. 10 power 100, it is nothing but, if the denominator it is 7, it is 6. 6 goes how many times? 6 16s are 96. Into 10 power 4 by 7. Into 10 power 4 by 7. These again nothing but 1. 10 power 4 by 7, again we did 4. Again we did 4. Finally, we will see with the third term what will be the answer. 10 power 1000 divided by 7. So these nothing but 10 power 6. 6 16s are 96. 6 6 are into 10 power 4 divided by 7. All the time you are getting 10 power 4 divided by 7. Every time you are getting 10 power 4 divided by 7. 10 power 4 divided by 7 is 4. For 1 0, I got 4. For 1 0, I got 4. For 2 zeros, I got 4. For 3 zeros, I got 4. For 10 zeros, I got 4. 4, 4. Right from 1 0 till 10 zeros, every time I got the value 4. Every time I got the value 4. 4, 4, 4, 4, 4. Added 10 times. 4 tens are 40. 4 tens are 40. 40 divided by 7. 7 fives are 35. What is the remainder? 5. 7 fives are 35. What is the remainder? 5. Again, I am repeating it. For this, I got 4. For this, I got 4. For this, I got 4. 4 is added 10 times. If 4 is added 10 times, it will become 4 into 10. 4 into 10 is 40. 40 divided by 7. 7 fives are 35. Positive remainder, it is nothing but 5. Positive remainder, it is nothing but 5. Very, very good question. Especially the students who are preparing for CAT examination, or it could be any other examination. In case if reminders is a topic, this class is a must attend class. At the end of the class, probably you'll understand in detail the complete chapter of reminders. Next one. Reminder 1. 53 power 17 divided by 19. 53 power 17 divided by 19. 53 power 18 divided by 19. It is 1. According to Fermat's theorem, we want 17. So these are nothing but 53 into 53 power 17 divided by 19. It is nothing but 1. 53 into 53 power 17. 19 twos are 38. Remaining it is 15. 53 power 17 by 19. I want the value. When I further divide, remainder does not change. When I further divide, remainder does not change. I hope it is clear. 15x dividend equivalent to divisor into quotient plus a remainder. So 15x is nothing but 15k plus 4k plus 1. 15k plus 4k plus 1. Divisible by 15, divisible by 15. This should be divisible by 15. This should be divisible by 15. If I take 15, 4k equivalent to 14, k is a natural number. 4k plus 1, it is an odd number. 13 not possible. 45. 4k plus 1 is 45. K value is nothing but 11. K value, it is nothing but 11. 15x is 11 into 19 plus 1. 11 into 19 plus 1. These 210. So x value is nothing but 14. X value is nothing but 14. Very, very good question it is. X value is nothing but 14. X value it is 14. If the denominator it is a prime number, numerator it will be 18. 53 power 18 divided by 19. 53 into 53 power 17. 19 twos are 38. 15. 53 power 17 divided by 19. X. Dividend equivalent to divisor into quotient plus remainder. Divisor into quotient plus remainder. 15x is 210. So x value is nothing but 14. Very, very good, high quality conceptual questions discussing in detail from the basics to the advanced level. In detail from the basics to the advanced level. Another very, very good question, sir. Very, very good question at an advanced level. Remainder 1. 7 power 7 power 7. 7 power 7 power 7 divided by 13. Remainder 1. 7 power 12 divided by 13. It is nothing but 1. Remainder 1. 7 power 12 divided by 13, it is 1 based on a Fermat's theorem. Then divide the power by this power. 7 power 7 divided by 12. These are nothing but remainder of 7 square whole cube into 7 power 1 divided by 12. 7 power 7 square power 3 into 7 power 1. 49 by 12. 1 sevens are 7. 1 sevens are 7. That means 7 power 7 when you divide by 12. 7 power 7 when you divide by 12. What is the remainder? 7. 7 power 7. When you divide by 12, remainder is nothing but 7. So wherever 7 power 7 is there, substitute this form. 7 power 12k plus 7 divided by 13. 7 power 12k, it is 1. So it is remainder 1. 7 power 7 divided by 13. 7 power 7 divided by 13. You can take any number. Suppose if I take 7 square whole cube into 7 power 1 divided by 13. 49 by 13. 49. 13 3s are 13 9. Remainder it is 10. Remainder it is 10. 10 cube into 7 divided by 13. 13 1s are 13. Negative remainder is minus 3. Minus 3 cube is minus 27. 13 2s are 26. Minus 1 into 7. Minus 1 into 7. Negative remainder minus 7. Positive remainder 6. Negative remainder minus 7. Positive remainder it is 6. I hope the idea it is clear. If the denominator it is 13, 7 power 12 divided by 13, it is nothing but 1. 7 power 12. So divide 7 power 7. Divide this number by this number. 7 power 7 divided by 12. 7 square whole cube into 7 divided by 12. 12 4s are 48. Remainder 1. 1 into 7, it is nothing but 7. So 7 power 7 is nothing but 12k plus 7. 12k plus 7. I hope the idea it is clear. Fermat's theorem, another application. Fermat's theorem, another application. Fermat's theorem, another application. So what all we discussed? Fermat's theorem. Fermat's theorem. When the Fermat's theorem is used, Fermat's theorem is used when the denominator it is a prime number. When the denominator it is a prime number. When the denominator it is a prime number. Very, very important concept. Very, very important concept. Listen carefully to this concept, sir. This concept can help you to solve some tough problems very, very easily. When the dr is nothing but denominator. Very, very important concept. When you divide 10 power p minus 1, 10 power p minus 1 divided by p, it is 1. P not equivalent to 2 comma 5. Can I write like this? Why? Because if p is 2, 10 and 2 are not co-prime to each other because both of them are multiples of 2. If I write 5, 10 and 5 are not co-prime to each other because both are multiples of 5. First write down this point. Remainder 10 power p minus 1 divided by p. 10 power p minus 1 when divided by p, remainder it is 1. P not equivalent to 2 comma 5. P not equivalent to 2 comma 5. See this example. 7 divided by 2. 7 divided by 2. 3 2s are 6. Remainder it is 1. If I shift 1 to the left hand side, 7 minus 1 by 2. 6 by 2. Remainder it is 0. 1 if I shift it to the left hand side, 7 divided by 2. 2 3s are 6. Remainder it is 1. 1 minus 1 0. From this concept, what we can do is, If I shift 1 to the left hand side, 10 power p minus 1 minus 1 when divided by p, it is nothing but 0. P not equivalent to 2 comma 5. P not equivalent to 2 comma 5. 10 power p minus 1 minus 1 divided by p. Reminder, it is 0. P not equivalent to 2 comma 5. Suppose if I take p value 3. These are nothing but 10 square minus 1 divided by 3. 100 minus 1 is 99. 9 into 1 divided by 3, it is 0. 9 is perfectly divisible by 3. P is 3. 10 square minus 1. 10 square minus 1 is 99. 9 into 11 divided by 3. 9 is perfectly divisible by 3. If I take p value 7, p cannot take lowest prime number 2, then 5. 3 anyway we took. If I take 7, 10 power 6 minus 1 by 7. These are nothing but 9 into 6 ones divided by 7. 9 into 6 ones divided by 7. 9 is not divisible by number. This number is divisible by 7. This number is divisible by 7. Now listen carefully to this concept, sir. Here 9 is divisible by 3. Here 9 is not divisible by 7. So these single digits, series of 6 is divisible by 7. Suppose if I write 11, 9 into 10 once I will get. If I write 13, 13 will become 10 power 12 minus 1. 9 into 12 once I will get. If the denominator is 3, 9 is not divisible by 13. The number in the bracket will have 12 single digits. If the denominator is 7, 9 is not divisible. I will get 6 ones. Very, very important key point. Extremely important key point. Very, very important key point. Please write down. The key point is like this. Key point is like this. Any single non-zero digit, any single non-zero digit written p minus 1 times, any single non-zero digit written p minus 1 times is always divisible by p, is always divisible by p. If p is a prime number, p is a prime number, p not equivalent to 235. P not equivalent to 235. If you understand this statement, it will be very easy to understand it by these examples. Please read the statement. Any single non-zero digit, any single non-zero digit written p minus 1 times, 7 means 7 minus 1 times 6 times is always divisible by p. P not equivalent to 2 comma 3 comma 5. P not equivalent to 2 comma 5 because these two numbers should be co-prime to each other. P not equivalent to 3. P not equivalent to 3 because 9 is a multiple of 3. Very, very important key point. Any single non-zero digit, any single non-zero digit written p minus 1 times, any single non-zero digit written p minus 1 times is always divisible by p if p is a prime number. P not equivalent to 235. P not equivalent to 235. First we will write down the concept. Once you understand this concept, then these two questions will be easy. Any single non-zero, any single non-zero digit written p minus 1 times, any single non-zero digit written p minus 1 times, p minus 1 times is always divisible by p, is always divisible by p if p is a prime number. P is a prime number. P not equivalent to 235. P not equivalent to 235. Any single non-zero digit written P minus 1 times is always divisible by P. Very, very important statement, sir. By knowing this statement, you can solve this problem easily. This is 19. Any single non-zero digit written P minus 1 times, written P minus 1 times, 19 minus 1 is 18 times, is always divisible by P. So answer for this question is 0. Answer for this question is 0. Just by looking at a question, 9 is a non-zero digit. It is written P minus 1 times, 19 minus 1 is 18 times, is always divisible by P. If P is a prime number, 19 it is a prime number. Proof of this concept also we discussed, and the application part of the concept also we discussed. Application part of the concept also we discussed. I hope the idea it is clear. Next one, some more examples we will solve. Then we will solve this question. Question is 5, 5, 5, 5, 5, 5, 5, 5 divided by 7. Divided by 7. 555 divided by 7. What is the statement we made? And if the denominator it is a prime number. Fermat's theorem is applicable when the denominator it is a prime number. If the denominator it is a prime number, any single non-zero digit written P minus 1 times, 7 minus 1 6 times, it is perfectly divisible by 7. It is perfectly divisible by 7 because 7 is a prime number. All these questions are very, very easy if you understand the logic. 7 is written 12 times. 7 written 12 times divided by 13. 7 written 12 times divided by 13. Any single non-zero digit written P minus 1 times, 13 minus 1 is 12 times. It is always divisible by 13. It is always divisible by 13. It is always divisible by 13. Suppose 2, 2, 2, 2, 2, 36 times. 2, 2, 2, 2, 2, 36 times divided by 19. 2, 2, 2, 2, 36 times divided by 19. What is the concept we discussed? Any single non-zero digit written P minus 1 times. What is the 19 minus 1? 18 times. What is the multiple of 18 to get 36? 18 twos are 36. Perfectly divisible. Answer is nothing but 0. Any single non-zero digit, any single non-digit written P minus 1 times, 19 minus 1 is 18 times. Any multiple of 36 is a perfect multiple of 18. Answer is 0. Now see this question. If you see this question, if it is 37, if it is 37, 7 is written 36 times, 36 times, the answer would have been 0. Any single non-zero digit written P minus 1 times, it is always divisible by P. 36 times. 36 goes how many times in 73? 36 twos are 72. So if the question is 72 times, answer would have been 0. One more extra 7 will come. One more extra 7 will come. If the question is 36, 37 denominator, numerator it should be 36 times. 36 times it is 0. Any multiple of 36 times also it is 0. Because first is one block of 36 0, another block of 36 0. Remaining it is 7. One more question. 5, 5, 5, 5, 5. 5, 5, 5, 34 times, 5, 5, 5, 5, written 34 times, divided by 17. 5, 5, 5, 5, 5, written 34 times, divided by 17. If the denominator it is 17, numerator it will be 16 times. Numerator 16 times, 16 twos are 32 times. 32 times it will be 0. 32 5s are out. Remaining 2 5s I got. So 55 divided by 17. 17 3s are 51. What is the answer for the question? 4. What is the answer for the question? 4. Again I am explaining. If it is 17 times, 17 minus 1, 16. 16 times answer would have been 0. 32 times answer would have been 0. So another 2 5s are left, which is 55. 55 divided by 7. 7 3s are 51. Answer is nothing but 4. Answer is nothing but 4. I hope the idea it is clear.